I'm Anil Kumar, and here is a practice question for you on weighted averages. Application is mixtures. So let us say we are making a trail mix where we are just mixing a few nuts. So let's say we have almonds mixed with walnuts. And let us assume that the rate for almonds is let's say $1.20 per kg, and that for walnuts is around let's say $1.24 per kg, right? Okay. Now if we mix them in different quantities, the mixture will have different rates. So we get a mixture here. So we'll call this as just a mixture, which is mix of almonds and walnuts. If I use same weight for each, that is to say, if I take case 1, let me take different cases now, and then we will continue. Let us say we use the quantities which are same. That is to say, if I use let's say 5 kg of each, right? If I use 5 kg of each, what is going to be the rate for mixture? So we'll find mixture rate. Okay, can you tell me this? If we use 5 kg of each, since the quantities are same, the average of these two should be 20 plus 24 divided by 2. So we expect the answer should be mean value of these two. We expect $22 per kg. That is what we expect. And if the quantities change, if I change the quantity, that is to make almonds more in quantity. Let's say we use 10 kg of almonds and we use, let us say, only 2 kg of walnuts. What should be the rate? We'll calculate it, but let's estimate. Since we are using higher weight of almonds which are cheaper, we should have less than $1.22 per kg, correct? But if we change the quantities to, let us say, reverse it, right? So kind of, let's say we use 1 kg of almond and let's say 5 kg of walnut. In that case, we expect that the mixture should be closer to the rate of walnuts because more walnuts are placed here, correct? It makes sense. So we say it is higher than 22 per kg. Is it okay? Or the other way is we can say it is closer to walnuts. It is closer to $24. Is that case? So what we see here is that if the weights are increased, then the rate is closer to that of the quantity, which is more in numbers. So that is what we will find in this particular example. So let us calculate the mixture rate for all the 3 cases. We'll call this as case 1, case 2, and case 3. Okay, so let's do case 1 now. So case 1, we have quantity and rate. So what is average? Let me write down the formula for average also. So when we say average rate, then what we are going to do is multiply rates with quantity to get the value, right? It is total value divided by total quantity. How do you get total value? You get total value by multiplying rate with quantity, right? So we say rate of 1 times quantity of 1 plus rate of the second item times quantity of the second item divided by the sum of quantities, correct, of first and second item. Actually speaking, this series can be extended. You can always add more than one item in a mixture, right? So you can add cranberries or anything else if you want. Okay, let's keep it simple for the time being. So I've taken up very simple values to understand the concept. So in the first case, the rate should be, let me call this as the average one rate, right? So average rate for the first case, we have quantity and rates given to us. So we'll multiply the rate with the quantity. So we'll say 20 times 5 plus 24 times 5 divide by total quantity, which is 5 plus 5, right? So let's use the calculator to calculate it. So we have 20 times 5 plus 24 times 5, which is equals to 620. Okay, so let's recalculate. So what do we have here? Which is 20 times 5, which is equals to 100, plus 24 times 5, which is equals to 120, divided by 5 plus 1 is 10, right? So that gives us 100 plus 120 is equals to 220, divide by 10 is equals to 22. So as expected, we get 22. The units will be dollars per kg, correct? So this is as expected, correct? So we got $22 per kg. Now let's calculate the average for the second case. In this case, the quantities have changed. Rate is same, right? So it is 20 times 10 plus 24 times 2, right? Divide by, the quantity is 10 plus 2. Let me write 10 plus 2. So it becomes 20 times 10 is 200 plus 48 divided by 12, right? So that is 248 divided by 12. So it is, let's calculate this one, 248 divided by 12 equals to, we get 20.66, right? So that is the rate. So what do we expect? Less than 22. We got it, right? So it is, the value is $20.66 per kg. The reason is, it is closer to elements since the quantity for elements is higher, right? Let's find the average rate for the third case, which is 1 kg of elements. So it is $20 times 1 kg plus $24 per kg times 5 kg divided by 1 plus 5. 1 plus 5 is 6. So we have 6 here, and this is 20 plus 5 times 4 is 22, and 2 times 5 times 1 is 10, and 2, 120. When you add it, you get 140 over 6. So let's figure this out. So 140 over 6, 140 divided by 6 is equal to 23.33. So you can see this rate is very, very close to the walnut rate, right? So it is $23 and 33 cents per kg, correct? So I hope this example clearly illustrates the importance of weighted averages. So weighted averages are same as the average if you are using the same weights, but it is different if the weights are different. It kind of swings towards the higher weight, and that gives it the name, right? So when the weight of elements was higher, the rate was closer to that of the elements. And when the weight for walnut was higher, the rate was closer to that of the walnuts. So I hope that helps you to give you a very clear picture about weighted averages. I'm Anil Kumar. You can always share and subscribe my videos. Thank you and all the best.